Today we're going to continue to factor polynomials. When I look at this first problem here, remember the first thing I want to look for is a GCF, or a greatest common factor. And in number one, I do not have a greatest common factor. So I'm going to go ahead, and it's a quadratic. I'm going to go ahead and put up two linear binomials. If I look at the first spots, I know that x times x has to be x squared. So I have to have x and x. My other option for the back end is 9. So I have 9 and 1, or my other option is 3 and 3. Now, remember, my goal is to get 0x when I add those together. If I put 9 and 1, then I'm definitely not going to get 0. So I'm going to go ahead and try 3 and 3. This would give me 3x and 3x, and then I just need one of them to be negative. And it doesn't matter which one. -3, +3. And that is it. Same thing here. I do not have a GCF. X and X, my only options, and then 36. Well, I can use 3 and 12. I can use 9 and 4. I can use 6 and 6. And remember, since these are both 1, coefficients of 1, I need this times this. I need that to add to 0x. So I'm going to need these to be the same thing. One's just going to have to be positive and one's going to be negative. So if I use 6 and 6, then it works, and then I'm just going to pick one to be positive and one to be negative. What's important to note is that it's kind of weird to see that 0x. So we won't ever really see it. We will see it something like number 3, 4, 5, or 6, where that 0x term is not there. So we just need to remember, same thing, something times something needs to be x squared, and then the back half needs to be positive and -5. And just make sure that when we go, okay, yeah, that gives me -5x, this gives me +5x, so yes, that 0x term will be there, okay? Same thing with 4x squared minus 16. Now remember, GCF, and that does have a GCF, so I'm going to go ahead and take a 4 out of both of those, right? And when I take that 4 out, I'm left with x squared minus 4. So I should go ahead and try and see if I can also do another linear binomial. Well, let's see, x squared. Let's see, x times x, that'll work, okay? And I'm going to do 2 and 2. Okay, let's see. That'll give me positive 2x and negative 2x, so that is good. And it gives me -4 on the back end. Same thing with number 5. I do not have a GCF. Now, I could use 4z and z and 1 and 1, but that's going to give me 1z, and this is going to give me 4z, which is not going to give me 0z in the middle. So it's important when we only have those two terms that they need to be the same thing. They just need to be what's called conjugates of each other, where one of them is positive and one of them is negative. But they have to have the same values. Same thing with number 6. Just because it's not written in standard form, this first piece, I know still has to multiply to 100. Well, let's 10 times 10, and m make 1 minus 1 positive. Let's double check that. -10m in the middle, positive 10m on the outside, -m times m is -m squared. Yep, we win. What's super important to note is that something like x squared plus 9 is not factorable because it's not a difference. Think about why. You might go, oh, well, that's okay. We'll do 3x, and yeah, that'll work, right? X plus 3, x plus 3. Well, it gives me 3x here and positive 3x here, which gives me 6x, but I need it to be 0x. So that's not going to work. And then you go, oh, well, duh, Mrs. Hewling, make one of them minus. But if I make one of them minus, yeah, that gives me 3x, and this gives me -3x, which is 0x. But 3 times -3 is not positive 9. So it's important to note that there are some times that we cannot factor things, and this is just not factorable. It is fully simplified.